Hi, my name is Chad Williams. Today we're going to talk about rough plotting. So these plots aren't for professional manuscripts. Really all they're going to be used for is checking your data really quickly. For professional plots, we're going to use ggplot2, but it's a little bit more work to get ggplot2 working, so we just want a way to quickly look at our data. So what we're going to do is we're going to use native R functions here. So what I'm going to do is I'm going to create a data variable, and I'm going to use cbind. So I'm going to create two columns and eventually I'll create a third. And I'm going to use this rnorm function. Now what an rnorm function does is it's going to randomly give you numbers from a normal distribution. So I'm going to ask for 100 numbers. Now if I ran this on itself, it's going to give me what I'm looking for. And it's just really a mean around 0 and probably a standard deviation around 1. I'm not entirely sure though. But what I can do is I can specify that myself. So I can specify my mean being 10 and my standard deviation being 4, for example. So that's going to be our first column here. And then let's add a second column, and then we're going to bind them together with this function. And we're going to say this one, it goes 100 data points, but let's say 20 is our mean, and then 6 is our standard deviation. So suddenly, with data, we now have 2 different columns and 100 different data points per column. Now, as per normal, we're going to add column names. So I'm going to use the same kind of paradigm where our first condition is lecturer style university teaching, and the second one is flipped style. So there is our data here. Cool. So let's look at histograms first. I'm going to just select the first column of our data, which is just our lecturer condition. So I just want to see how the points look in that condition. And what we see is a normal distribution, which makes sense. There looks like some sort of a skew, and we could definitely change parameters like the bin count and stuff, but I'm not going to get into that here. But the idea here is we have normal distribution, and that makes sense because we actually sampled from a normal distribution. And of course, if I want to see the second condition, we just run it again with number 2, and that looks a little bit more normal than the first one did. Now, one interesting thing is we have these arrows here, which means I can actually go back to the first one and see it like that, and then go back to the second one. But we can also subplot if we want. So we could do that with this, par mf row equals c 1 to 2. What this means is we want 1 row and 2 columns, and the 2 columns is for each of our plots. So if I do that, what I'm going to do is I'm going to just copy paste this one to be the second. So I run all of that, and I don't have to run it all at once. So there's one, and what it does is this is going to populate the first subplot, and this is going to populate the second subplot. And there you go. Now if I do it again, or if I run this one again, it's going to start over basically. So now this one starts at the first place, and it just kind of keeps reoccurring in that way. Now I'm going to move it back to just a single plot, and I just do that by using the same function, but saying I just want 1 column and 1 row here. Okay, so now we're going to be back to single plots like we see here. So what about plotting a scatter plot? That's as easy as using the plot function. We're going to just put in data here. Okay, and there we go. So now we see, oh, there seems to be some sort of possible outlier here. But what we see is the lecture on the bottom, or on the x-axis, and flipped on the y-axis here. And it's just a scatter plot between the two. But what you'll notice is I just put data in, but that only worked because I only have 2 columns. So let's add a third column here, and I'll show you how to do that without only 2 columns. So I'm just going to add a mean of 5 and a standard deviation of 8. Then we're going to add a new label. There we go. And then suddenly, if we do plot data, it's just going to take the first 2. But what if we want the second and third? So just like we did before, we're going to use indexes. So I'm going to say I want the second and third column here. And there you go. Easy enough. So what about bar plots? Now bar plots are a little bit different because what it actually wants from you are means. It doesn't want to calculate the means for you. So we're going to use a function called colMeans, which is a column means function, and we're going to do that for our data. So if I go bar plot without an S, colMeans data, what I get is 3 different bars. What about box plots? Now we're not going to use the col mean here, but we have data, and there you go, box plot data. Great. And then just like I've said before, if you're really just focusing on two of these columns, for example, the second and third, it's as easy as just using the index there. Now we can make a line plot as well, but this is a little bit different because we need to first set up a plot. So what we're going to do is we're going to go plot, col means data, and this is just going to give us 3 single points. Then we're going to go lines, col means data. And so what this does is it creates lines between these 3 data points. And those 3 data points, just like our bar showed, were our means. Now, this is really quick, and like I said before, this is just rough plotting. So this is just ways to look at our data. And really this plot here is a good example of why we always want to plot our data before we get into statistics, because we can see that there's one data point that's really far to the left on the lecture variable. So it seems like it fits pretty well within the flip variable, but the lecture variable is below 0, and it's the only one that's below 0. And of course, these are arbitrary numbers that I'm making up, so it's possible it's below 0, but why is it so far from the rest? And you might want to investigate that.